Alright, today's lesson is identify quadratic functions in their graphs.
I am for just a few days.
Kansas City is known as the City of Fountains. One of its famous fountains is pictured at the right. The streams of water from fountains all take on the same basic shape. The shape of the water shooting out of a fountain is a curve called a parabola. A parabola is the graph of a quadratic function.
Thank you.
You're welcome.
Okay, so the key concept, you need to write this down. A quadratic function is a function that we can written in the form of f of x equals ax squared plus bx plus c. That should look very familiar to y'all. Or y equals ax squared plus bx plus c. A cannot equal 0 on either of them. This form is the standard form of a quadratic function. If a equals 0, it would just be a linear function. A quadratic function is a parabola. So you also need to write this portion down. That when a is greater than 0, the parabola opens upward. When a is less than 0, the parabola opens downward. So we know how to determine if a number is greater than or less than 0. So basically, if it's a negative a, your parabola will open downward and it will look kind of like it will look like an upside down U, like someone doing a little back bend or something. I should do upward first, and upward first will look like a U, an actual U, and downward will look like this. So I need you to go ahead and write that down in your interactive notebook. Okay, we want y by itself, so that means you should have subtracted minus 3x squared on both sides. So you'd have negative 3x squared minus 3x squared. This would cancel out and you'd be left with y equals 3, You'd be left with y equals negative 3x squared plus 2. Or you would have had 2 minus 3x squared. Well, if you notice here, my a is a negative 3, so this would be open downwards. And why? Because a is negative. Alright, tell whether the graph of the quadratic function opens upwards or downward and then explain. So, y minus x squared equals 3 plus 2x. If I could go back to my first slide, I would tell you that I need to make sure that it's in standard form. And a way that standard form looks is f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. So I need to make it to where it looks like this. This could either be f of x or it could be y. Well, if I look here, I have a y. So that means I want y by itself. I need to rearrange this. If you don't understand that, then pause the video, rewind, and see if you understand it the second time you hear it. So, y minus x squared equals 3 plus 2x. Well, I have y over here. I want y by itself, because that's what it looks like in the formula. So I need to move over my x squared. Well, how can I do that? Well, it's a minus x squared. To get rid of minus x squared and move it to the other side, all we're doing is making it go to the other side. I just have to add plus x squared. So I add plus x squared. So what happens is that cancels out and I have y equals 3 plus 2x plus x squared. So now I have everything on one side and y on the other. In order to move that, now what I need to do is make sure that it's in the correct order, and it looks like this. So if you notice, I have my x squared first, so I need to have my x squared first. This is all positive, so I don't even need to worry about if I have negatives or minuses in there. If there was a minus in there, then I'd be more cautious of the order that I move it in, because I need to make sure the minuses or the negatives go with it. So since these are all positive, I can just simply rearrange it. So I will have my x squared first, plus Then I have bx next. So that means my 2x is next, plus 2x. Then I'll have my c next, which is my constant, and it's by itself. So then I just drop down my y equals x squared plus 2x plus c. Now it's in the correct form. Now I can determine if my a is positive or negative. I probably could have determined that before, but I really want to make sure that I know what I'm doing. And it's important to do these steps because you're going to need them later on when we're doing this. So, if I look here, y equals x squared. This is my a value. This is my b value. This is my c value. And the only thing I need to know to determine if it's going upward or downward is what my a value is. Well, a equals 1. There's nothing in front of my x. A is positive, so that means it's going to be going upward. And it says explain, and you can put because A is positive. And you better spell because correctly. I will be very angry if I see B-E-C-U-Z. Because, now I forgot what I was putting. A is positive. Alright. So I want you to pause it, and then I want you to see if you can do the second one on your own. Alright, here's what I want you to do. I want you to pause this video, and I want you to write every single thing that's on this page. That includes this graph. I want you to draw this graph. And I know you're capable of doing that even if you don't have graph paper. So I want you to go ahead and draw it. Okay, so if you have colored pencils at home, I suggest you get colored pencils to help you with this. I color-coded my definitions to go along with the picture to help you, and I believe it will help you if you do this at home. So, for the parabola shown, identify the following. Vertex, maximum or minimum value, x-intercepts, axis of symmetry, domain, and range. So, my vertex is my turning point. Everything on this, axis of symmetry, maximum point, x-intercept, domain, and range, well, not domain, but range, you can find out just by looking at your vertex. So my vertex is the turning point. So my vertex will be right here. The turning point just means right here it goes up, 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 down, 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 down. So here's my turning point. So my vertex is at point 0, positive 9. So I put 0, 9. Uh-oh. So now I'm going to look at the definition of axis of symmetry. Axis of symmetry is the vertical line that goes through the vertex of a quadratic function. Wow, a lot of big words. It's all about comprehension. So let's think about what a vertical line is. A vertical line is a line that goes up and down. It goes through the vertex of a quadratic function. Here's my quadratic function. Oops, you can't see it. Here's my vertex. It's a line that goes through it. So this would be my axis of symmetry. I'm going to use orange because that's what I've been using. So here's my axis of symmetry. So it says just your x value. I know I wrote that in late, so you might have not gotten it. Your x value, well, my x is 0. So again, looking at your vertex, you could have figured that out. My maximum point, it says find your maximum or minimum value. I've already defaulted and put maximum in there. Maximum or minimum value. Well, if you look at your parabola, you have a maximum value right here because it's opening downward. If you were going upward, you'd have a minimum value. So it only makes sense to have a maximum value because it's going to open downward. My maximum value is my highest point, which is the y value. So I'm going to put y equals, oh, you don't even need to put y equals. My maximum point is the y value, and that is 9, because 0, 9 is my highest point. So, again, just looking at my vertex, I could have figured that out. Oops, I lied. You can't find out the x-intercepts from looking at your vertex. My x-intercept, I'm going to be using green, is exactly what it is. It's points where the parabola intersects the x-axis. So, here's my x-axis. Here's where my parabola intersects it, right here and right here. So that means that my x-intercept is 0, -3, and 0, +3. So, -3, you just have to put your x values, and 3. All this is definitions. This is just straight up definitions, trying to understand definitions on a parabola. So the domain for every single parabola where it's ax squared plus bx plus c, where y does not equal 0, your domain is a set of all possible x values. Well, it's going to be the same for every single one you do. So you can either memorize this or you can understand this. I choose for you to understand. So the set of all possible x values, if you look at your parabola, it keeps going, and I'm going to try to see if I can move my face. And I can't. And I wish I could. Alright, well, just imagine this, because it won't let me go down. So, if you notice, if your parabola kept going down, that's what those arrows indicate, that it keeps going, your x values will go on forever. Your x values are the first numbers. So, if it kept going and kept going and kept going, it would never end. So, your domain is the set of all real numbers. So all you would put is all real numbers on every single one. Or you could write -infinity to +infinity. Okay, so I can explain the domain more tomorrow. For time's sake, I just want you to know that. So range is my last thing. The range is a set of all possible y values. Well, let's look at my parabola. My y values, this is my y-axis. If you notice, there is a stopping point on my y. Where is it? Well, it's at your vertex. It's the highest point. So, my highest point is 0, 9, which means my highest y value that I could possibly have is 9. Right? If for some reason I had a low value, my lowest point would be 9. If it opened upwards, if that makes sense. So my range would be y, anything that is less than or equal to 9. Okay. So this is your only example that I want you to do in your spiral. I want you to find the vertex, maximum minimum value, x-intercepts, axis of symmetry, and domain and range. And I want you to do this to the best of your ability. Like I said on the slide before, this is basically vocabulary. It's comprehension. So you need to do the best you can. Tomorrow when you come into class, we will go over this.